This is scene 4 and it has this sort of swirly black hole effect. And before I look at modifying this scene, I want to look at how this effect is generated. Well, in this case we've got the effect laid over itself, so there's two components to this. There's the volumetric cloud and a smaller version of the volumetric cloud lined up over it, so you get that sort of very fine vortex in the middle there. This component is exactly the same as that one, it's just scaled slightly differently. If we look in the material, you can see that it's composed of 3 texture channels, a mixer here which is determining where the middle fits into the outer, but both are quite similar in the fact that they're spiral shapes. And if I go into the deep texture editor, and I touched on this in the last video, we'll talk about it a bit more till eventually hopefully we can get the idea across. We've got a spiral generated by Vortex Noise, a distance origin blob, another distance origin blob, and combined and moved using phase so that it's, in this case, at the origin, which makes life a bit easier when it comes to combining together with another such spiral at the origin. So this bottom left hand corner here in object space represents, if it's not been adjusted by the transformation tools through this offset, the center of your object that you're applying it to. So you can see just from above, you can see we're looking down the spiral there to give you some idea of the orientation of this. So with this, the vortex noise, the phase here is a fractal and it's giving it its fluffiness. So that's taken the initial function and just disrupted it with a fractal phase. In this case, the next channel, this is distance origin and it's been pushed along sideways by the phase, so it lines up with the middle of this vortex, and the same with this. And then for the final combination, phase has been used again to push this lot back to this edge so that it's lined up on the origin. And if you can get your head around this process, then you can utilize any of these vortexes inside here to create new galaxies or black holes or other spiral effects. So what I thought I would do is I'll take this material, reset it to default grey, and in the first blob, just in the diffuse channel, what I'm going to do is use this basic distance origin, which is this I, and you can see that under normal circumstances it might look like this when it comes out of the library, but this X rotation here has rotated it so that it's looking upwards. This is a scaling factor which in the transformation tools allows you to make this look larger or smaller. Now if we just look at this very simple texture component here, so we've got 2D, which means that it's like a cylinder. If it was 3D it would be a sphere, and if it wasn't moved from the origin, so if we made both these into 3D so that they're now spheres instead of cylinders, then the ball will appear blank unless you use the offset to try, and I'm not sure whereabouts it is, but somewhere in here we should be able to offset it so that the eye appears on the top of the sphere. But that would mean we'd need to know how many Bryce units, and it may only be a very small amount, that this is orientated. And the other thing is, of course, I've rotated it, so that makes life a bit more difficult. So somewhere in this is lost this, or it's now outside it. We know that it's definitely inside it here, so if I was to lower the scaling, we're looking at the shells of this because they're concentric with the center, and then we could use this as a clue by lowering the scaling to offset it. So the y-axis, because we're rotated 90 degrees, is out the side, so that would tell us with a bit of investigation that we should be doing it maybe on the x-axis to get it to move up and down because of the rotation. Oh no, it doesn't seem to have worked either. Let's try Z. Z's giving us, let's set that to 0. So this is really just a way of investigating. So if I now scale this down and then adjust the Z, what I've got is a sphere that's based on the origin here, offset. So you've got to imagine this as a blue sphere in 3D space intersecting this object sphere and it's picking it up on the surface. Now it's a bit more helpful with the volumetric materials because you can actually see inside the volume of the material, so you've got a better chance of lining things up, and it's less fishing blindly for the surfaces to intersect. However, right, let's just reset this, in fact, so that we're back to dealing with 2D, because that's a little bit easier. So if we go back to 2D like so, then we'll have no alignment issue, because this is now a vertical cylinder with blue on the outside and black on the inside, and no matter how we offset it on the Z direction, because we've rotated it, it won't be modified. So just taking that three-dimensional element out of that. So moving this around, what I'm going to do is in the third component I'm going to add some vortex noise. So I need to, I can have it 2D or 3D. I think I'll have it 3D because I can have it 2D. It just makes life easier, I suppose, if it's 2D. I need to set these down to 0. If you want to adjust these finely, and it can be a bit fiddly, use the right mouse button to click on the arrow, and you can do it one at a time. If you need to reset this one to that one, hold the Alt key down and click on the one you're wanting to match it with. So I'll just scale this in till we can see a vortex, and I'll add some colour. So we'll add some colour and take the bump off because that's rather ugly. Add some alpha channel and then blend it. So I want to line this vortex up with the centre of this distance origin blob, and this is the essence of the problem you're faced with if you want a spiral galaxy based inside some kind of function. You need to get it so that this is appearing inside the middle of your sphere that you're applying it to, which can be done using offsets, but then it offsets the centre of this. So if you want a bright centre, say this is the centre of the galaxy, which is, you know, how it's done, you want that blob to line up with the centre of this blob. So you can use the phase function to move these things around, but if you do that you also lose the opportunity to disrupt this with a fractal function to make it fluffy. So, but I'll show you how that works. So if you were to use, you can use either sine or square. Make sure that your frequency is set to 0, so it's giving you just an offset amount rather than applying a pattern, and then put the phase function in, and you can see at this point it's moving it to the left. So that might seem promising, because if you got that spiral down to there you could shift it across to the left. However, I'll show you why that doesn't work quite so easily. So spiral's down there, go to the phase function, it switches it to the left according to the rotation of the noise function. So it's not quite that easy. In the phase function you could go to 2D, in which case it moves it diagonally, which is not so easy to see unless we set that to 0, and then we'll do it like so. And if you're using a 3D phase function, and this is where your imagination is needed, it's going to, if this is a 3D function, we set it to 2D, didn't we? If this is a 3D function, it's going to affect it in yet another different axis, which isn't very clear. We'll use sine for this. It might be sine for this one. Here we go. Sine. Right. You can see it looks like it's rippling, and the reason for that is it's moving it both in the X and the Y and the Z direction, and this is a slice through the Z direction. So even if we were to select a different display mode, it won't really make a lot more sense. It'll just look like the pattern's transforming, and that's because the slices that have been on this projected surface are changing. So that's a bit of a visualization issue there. So if we can use either for the phase sine or square, but square obviously for 2D for some reason, possibly because of the when you add the next stacked layer it produces 0 output. So I'll stick with sine and switch it back to 2D. Will allow us to move this across, but it's no good to us that, because no matter where we put this vortex by rotating it anywhere we want, we can't actually get it to line up with the origin here. And the other thing, as I was explaining, was the sine function here is good for disrupting. Instead of using a sine, we could use a fractal here, take the frequency up turn it to whatever we want, 3D, 2D, and we can disrupt. I think that's in an extreme sense. We can disrupt these spirals to make them look more cloud-like. So you'd use, say, a fractal and give it a few octaves and increase the frequency, so you can create a nice swirly cloud effect, because otherwise the spiral's a bit plain. But that doesn't really solve our problem of getting this to the origin. So it's done in 2 stages. First of all, the first stage is you set your vortex up however you want it to look, and I'm just going to set it 0, 0. It could be there, and then we're going to move this using the sine function over to the center of that. Okay, and then having done that, what you do is move this in here back. So this isn't subject to the, this has its own orientation. So we move this to the middle of that, and then move that back to here. Alright, to move that out there, I'm going to need to place that so it can be moved back to here. I know that seems, you've got to think of these things. So put that down there, right, and then we can move this in the final phase if we give it sine or square, but with no frequency. There you go, 1D, and then we can move that. Oh, it's not quite made it. That's okay, because square will move it further. So there we go, that spiral now is here in the center, the origin, which is where I wanted it, which means when it maps using the mapping mode, it'll appear wherever I want to place it at the origin of the object. However, you can see the problem here, that this area is moved off, which is why we need to move this. We can move this, it's nice and symmetrical, using the phase function again. So we select the sine, see if it's going to move far enough. It'll depend on the scale, and then, right, okay, we need to set this frequency down to 0, don't forget that step. And then give it the sine, and it shoots off to the left. But bear in mind, with this noise function, we could rotate it round 180 degrees, and then I can move it across to the right. Because the scale of this is smaller, it'll move a lot further than this, because I had to scale this in. The steps of the offset are much larger. So if I wanted to make this, oops, I need to set the noise function. If I wanted to make this a smaller dot with respect to the galaxy, then I'd have to give it more phase to move it across to the center. So there you go, that's now lined up with the center. And the same can be done with this. So we could use this as a clipping filter to cut out the rest of this noise, so you only see the spiral. And this again would be a case of using a sine function or a square function, whichever's going to give you enough, setting the frequency down to 0. There we go. Then making sure we rotate it. Well, we know what the rotation is, because it's going to be the same as the rotation for the first one, because it's the same function. So that's 180. That's fairly straightforward. So it just pushes it along to the side, and we go like so. Set that to 180, and then use the phase to line it up. It's a bit chunky, that, so we'll just shrink it down a bit so it's more appropriately sized, and that fits over there. So when you've got all these things lined up, then you've got the, if we can just zoom in on this example, so I can show you. There you go, that spiral is now more or less lined up over that dot in the middle, and then there's the outer circle, and that is in essence the setup. Obviously you're then left with the challenge of setting the appropriate blend modes and mixing things together. However, you're not really, because I've already set these materials up. So long as you understand how things are moved around, so we've got the component on the left, which is giving us our spiral galaxy, and these are the positions of the hole in the center. Well, it's not a galaxy in this case, it's a black hole, but they're more or less the same thing. So if we go to the noise for the first function, this is our rotation. So if we wanted to swap the vortex for a different one, we need to move it around, and it's moved outside the field of the square. So that's a bit awkward, but we could bring another one in here, for example. There we go. There's another one there. That's like a double spiral. You can see there that's actually leading on to something else. So if you can line that up so that that's lined up with that dot by modifying the frequency, you could do that. Or you could move the dot, so you could move this in and then move the dot to match. But in the vortex noise, you'll find there are lots of vortexes around, and you can fish them out and then get different effects. So here we go, we've got a different spiral effect by picking out a different vortex, and we didn't even really have to modify the material that much. So that's what I wanted to expand on from the last one. I know it's a bit of an awkward topic, but we'll chip away at it, and eventually, hopefully, then you'll be able to take these functions and, knowing a little bit about how they're structured, be able to modify them to create your own materials and then save those to the library, or create your own objects. In this case, what I'm going to do is I shall get rid of that one and get my black hole effect, and what I'll do is select all the other things and attribute and hide them. Oops, I've hidden my black hole effect as well, so I'll just unhide that. Okay, and show you how you could use this effect in a slightly different way. So if I just reset this to a sphere, and bear in mind it was rotated so that you could look down the pole to see the effect, so like so. If we can rotate this so we're looking down the pole, which just means lining this sphere up, rotating it round so that the ends line up, which is a bit fiddly, I know. Don't know what space we're doing this in. Right, okay, and then enlarge it. Should be able to get it so we're like peering into the vortex like this, which is a nice effect, I think. So if I can just move it around so that we're peering right down it like so, and then modify the material, take the quality up to 50 to just improve the quality of the effect. There you go. You can see that because it's additive, it's working with the glowing stars nicely, and as I did before, we could easily convert this into a backdrop. And the reason you might want to do that is with the other objects in the scene, then you can have problems with clipping. But that doesn't mean we can't use this close to the asteroid, for example. We could have this as the backdrop, put that behind the effect we're going to use, and then put another vortex effect in the front and layer it in that way. So we'll just do that fairly quickly, so we have we've actually got somewhere in this, and I've not just talked about phase the whole time. So file, export image. Let's see what we're up to now. 3, even though it's for file 4, we'll call it 3 because it's the next one we made. Okay, right, I'll do a revert to saved, so we're back to where we were before. Get rid of the larger effect and save my camera position, take my perspective camera. You should be familiar with this process now, so I won't be too laborious about it. Set all these to 0. Down here, just go to the create shelf, click on the little gold man, navigate to my backdrop. Okay, check out of that, zoom in a bit so I can see what I'm doing, modify the attributes for this so that it's on the ground, and then move it along the z-axis. Let's see, that is obviously I was in object space there, or world space, so that's going to go behind the asteroid and hopefully not interfere with anything else. So I'll just link that to the perspective camera, so when I restore my camera position it's there, ready for use. Expand it, modify the material so it is additive, and if it's got, you see it's chosen a very strange selection of blobs there because these other two channels aren't active, so I'll just tidy that up and make sure we've got it ambient output to drive the effect. See that it's in position. Okay, and then I'll take this black hole effect and rotate it round a bit so that hopefully I can figure out which direction is going to make it point right at the camera. I know it's in there somewhere. There we go. Right, expand it, and as long as it's not touching that, I can probably get a hold of the effect. I seem to get in hold of everything else but the effect. Let's see where we are with this. Okay, it's not lined up with the centre of that. It needs to be bigger, or the asteroid needs to be smaller. So I'll get my effect, enlarge it. I don't think it's really a black hole now. We're in object space, so you slide it along its axis just there. and see how that looks. Okay, I just want to get these two lined up, which shouldn't be too difficult. If I can just figure out my orientation here. There we go. So, and enlarge it a bit further. How are we getting with this now? Nearly there. Move it off to the left. So, oops, it's looking quite dramatic. And there, take my asteroid. I think it's probably going to be easier to make the asteroid smaller and move it to the camera than it is to reposition the whole effect. So we just move that in towards the camera and up so it's clipping through this cloud. Alright, okay. So there you go. I think we've got the swirls going in opposite directions. And you can see the stars have doubled up, but that's okay. I captured the stars in the background as they've doubled up. So I'll take this effect and I'll not rotate it that way. I'll rotate it fully around that way, and hopefully then the spirals will line up together. Looking a bit bright there. Let's rotate again. There you go. It's not looking quite so bright now, depending how the spirals line up. So there you go. That's these stars that have been captured in the background are sort of stacked on top of one another, so it looks like they're streaming forward, which is a nice effect. And I think I will call that it, because I've gone on for rather a long time now. So I hope you found that interesting and instructive, and that bit by bit we'll learn to experiment with the deep texture editor, and that'll allow you to create more materials from the ones that have been supplied. Cheers now.